Okay, so this is going to be the next video in the series. It's going to be video number 7, I believe, and we're going to discuss the message loop, okay, of the Windows programming aspect. So let's do a brief overview here. Let's just recap what we did before in the previous videos. Okay, so the first thing first, we declared a window class here, okay, which is a structure. And then what we did, we initialized the structure to the various aspects of the window class. So initializing like icons, cursors, window procedure here. Okay, and then we registered that window class with the operating system here. Okay, and then what we did next, we based on that window class which we created here. Okay, we created our window. Okay, we called it create window to create that window, and then we we requested that the window be shown, okay, by calling show window function, and then we called update window, which basically repainted the client structure if basically we requested to have the client area of the window repainted if it was needed. Okay, so at this point we're going to go into the message loop. So let's begin here. So the message loop begins with a message structure. So we have to declare a message structure here, and we also have to declare a bool value for return value that we're going to get back from the get message function to test it. Okay, so first thing, so we're going to call first get message. So what it does here, the get message function, what it's going to do for us is basically retrieve the message from the message queue for our window, okay, for our application basically. So what we do here, we pass in a message structure by reference. So we're passing in the address of the message structure, not a copy of it, but just the address. So we're passing it by reference. The next variable here, it's a handle to a window. So we're passing it null here. So that means we want messages for all windows that belong to our application. And we put 0 and 0 for the filter. So the minimum filter and maximum filter, we put 0. So we don't want any filtering then. At this point, we're going to get a return value. So return value can be one of three options. Can be -1, which means get message got some sort of error. Can be 0, which is basically to exit the VM quit message, which basically going to exit the loop. And we have something greater than 0, which basically is going to mean that we retrieve a regular message. If we have a return value of -1, that means we get an error. So in this case, we're just going to exit from the application altogether. So we're going to display a message to the user, and then we're going to return 0, which is basically going to break the loop. If that's not the case, we got something greater than 0. If we got 0 itself, then if this is equal to 0 here, okay, then what will happen? The message loop is going to end by itself. And we have something greater than 0. We're going to call dispatch message, and the dispatch message is going to forward this whole message here to the correct window procedure function. Okay, so let's begin here by first looking at the type definitions. Okay, we're going to see a couple new type definitions. dword, okay, is basically defined as long value, which is basically 32-bit value, 4 bytes. Okay, usually it can be more depending on the compiler, but in our case, on 32-bit machine, it's usually 4 bytes. We have a long value, which is basically a long. We have bool value, which is defined as win bool. Okay, and win bool is defined as integer. So bool value becomes basically an integer value. Okay, so that's the first thing. Okay, so bool is basically an integer value there. Okay, let's look at the next one here. So let's look at the message structure. Okay, the message structure is composed of several variables. Okay, some of which will be passed on to your window procedure, others who are not. Okay, so let's look at the message structure. So message structure has a hwint, which is handle to window, unsent integer message, which is basically an unsent integer value, w parameter, which is basically also an unsent integer, w parameter, l parameter, which is basically long value. Okay, d word time, which is basically selects the time when the message was generated, the point, the location where the message was generated, and long value, which is private. Okay, so we have here our window procedure definition. So as you can see, the window hwint is passed, message value is passed, w parameter is passed to our function, and l parameter value is passed to our function. And just to give you a comparison, the l result is basically a long value standard call. The callback is basically a standard call, which is the calling convention, which means it goes really from left to right on the stack. The parameters, those parameters are pushed from left to right onto the stack, and that the I believe caller cleans up the stack when the function exits. Okay, then we have window procedure, and hwint is basically a void pointer, uint, which is basically an unsent integer, w parameter, which is also an unsent integer in the definitions, and l parameter is a long value. Okay, and so basically, let me just go here. So when we compile our program here, so the point, so like when we move the mouse, okay, messages are being generated, and whenever the message is generated, it's going to select where the tip of the point was for that for the mouse here, where basically what happened to the cursor when the message got generated there, put into the message queue. Okay, so now let's go here. Let's look. Let me just go. Okay, so let's look at the. Let's see. Let's look at the get message function first. Okay, let me just see here with the message structure. Okay. Okay. Yeah. So actually, let's look at the point structure first. Sorry. Let's look at the point structure here. So point, it's basically point pt. It has two variables, long x coordinate and y coordinate, and basically it's a long type. Okay, and just specify x coordinate of the point and y coordinate of the point for the message structure here. Okay, so that point here is the message structure. Okay, so let's see here. So let's look at the get message function first. So get message function takes a couple variables as its parameters. So that takes a pointer to the structure. So you have to pass our message structure by reference. Takes a handle to a window, and takes the message filter minimum value and message filter maximum value. So basically, this is here we're putting a pointer to the message structure that we're declaring. So in our case here, so this is basically the message structure is a regular structure, and we're passing the address of that message structure. So that's the pointer. The next is a handle to a window. Okay, basically we're passing a handle to a window with messages to retrieve. We're putting null in there, so we want basically to retrieve all window messages that belong to the window to our thread. Okay, so no matter what, as long as it's, the window belongs to our application, we want the message for that window, and we're putting 0 for the minimum and 0 for the maximum. Basically, when you put 0 for minimum and 0 for maximum, you're basically telling the system not to do any filtering. And even if you specify, let's say, a range from, let's say, 50 to 300 or whatever the case may be for the type of message you want to retrieve, the WM quit, window message quit, which is basically a 0 message, it's still going to be always be retrieved. Okay, it doesn't matter whether you have a filter or not, that VM quit message will always be retrieved from the message posted message queue. Now, the next thing is, let's look at dispatch message function. The dispatch message function also takes a pointer to the message structure and then sends it to the correct window procedure which the message is intended for. So for example, in our case, let's look at the small program here. In our case, we have two windows. We have our main window program, which has a main window procedure, and we have a button program here, button window, which has a window procedure button. So the dispatch message will call the correct window procedure for which the message is intended for. Okay, and the return value, which is L result, okay, which is long value. Return value is the value returned by the window procedure that the dispatch message called. So the return value here, it's usually disregarded. Okay, it's just for on reference, but usually it's the system like you don't need to know this, like the return value from this function 19% of the time. Okay. So now let's look here at the get message. So basically, here's how it works. Okay, so we have the message structure. So then we call our while loop. Okay, so the get message with a message pointer null. So we want all the window messages for all the windows in our application. We have no filtering, so we put 0, 0. So the first thing first. So what will happen when you put by a reference? So we put a reference to our method structure. So basically, like in a computer memory here, we're passing the address of our message structure. Let's assume this is the message structure here. Okay, in the computer memory. So we're putting the address of that message structure, passing to the get message. Then what will happen? The get message will basically retrieve a message from the post message queue and place it into the message structure for us. So that will be the second step. So first step, we're gonna call the get message function, which will in the second step will place, if the post message queue has a message, then it will place that message into the structure. If the post message queue is empty, there is no messages there, then that get message function will not proceed. It will basically be hung there. It will wait until a message is available, and then it will continue. So if no message is available in the post message queue, then no message will be retrieved, and get message will wait basically for message to arrive. Then what will happen? The get message function will test if it's not 0 or if it's not -1. So now I just simplified the loop here for demonstration purposes. So if it's not 0, message will continue. It's going to call dispatch message. Dispatch message will be called. The dispatch message, what this will do is basically it's going to forward that message information to our window procedure here. So it's going to forward the handle to a window, the message value, so what type of message it is, the W parameter to our window procedure, and L parameter will forward that information to our window procedure. And the way it knows how to forward that information is, as you know here, when we called in here in the window class, in part of the window class, when we had to fill in the information, we have to specify which window procedure belongs to that class. And then when we created our window based on that class, so we'll link that information. So the system knows which messages are intended for which window, okay, based on the window cluster, okay. Now, so let's continue on here. Okay, and then what will happen also, you need to know that get message basically retrieves messages mainly from the post message queue. Now there's another queue which is called send message queue, which is less documented. You can think of the send message queue as basically calling your window procedure directly, so without having to calling get message. This may not be 100% correct, because I read the documentation is very weak on this information, but some documentation saying that the post message, the send message, also going at some point to the get message, okay, to this function. But it's easier to think this way. So think of get message as getting messages from the post message queue, and then calling dispatch message to forward to the right window procedure, and send messages when you send a message to your window. Think of it as the operating system calling it the window procedure directly for you without going to the get message while loop. Okay, so that's the easiest way to separate those two. Okay, to think that way. So let's proceed here. Get message. That we covered that. We covered dispatch message. We covered. Okay, let's look at this thing here. So like what happens here It's as follows. Actually, yeah. So let's cover this option here. When you launch your application, the operating system is gonna create a process for your application. Okay, so it's basically a memory area in the operating system. Okay, in that part of the process, the operating system is going to create a counter for you. So it's going to keep track where the program is in its execution point. So it keeps track at at which point in code it's executing for that application. A heap area, so it's basically a dynamic memory area where you can allocate memory dynamically for your program. Your code memory area, where it's going to store your code. It's going to load your code into memory for execution. It's going to keep track of the registers, which is basically it's used by the CPU to execute your code. So it's like whenever you try to execute code, your code is loaded to the registers, and then it's executed by the CPU. And keep stack. Basically, the stack is used to keep track where in the which subroutines have been called. And when the system creates the process for you, inside that process, it creates a main thread for you. If you have for your application to execute, because it's a multitasking system, so that we can switch from one program to another. They run inside a thread, so that means each program gets allocated slice of the time to run, and the system that we can switch between one application to the other seamlessly without having to having to close one window in order to access information in the other window. So they run inside a thread. So basically, a thread is basically a lightweight process, basically. Okay. And here I have a demonstration here for you where your code inside the main thread, you can generate also subthreads, smaller threads, okay, that you can use for your own purpose inside it. So you can subdivide the thread into smaller subthreads. So you can have multiple threads inside an application. Okay. Now, so let's cover this here. So yeah, so counter. The counter keeps track of where the computer is in the execution process of the program. The register is basically the data holding place on the CPU for storing instructions for execution, address for data access, or any other data that might be needed by the CPU. Stack is the data structure that's used to keep track of the information that has been passed to functions. So basically, the variables that you pass into a function, they go on the stack. The heap is the area of the computer memory that the operating system gives you a process so that your program can use it to allocate space at runtime during execution for the data storage. And the code is the computer program that you write, basically the text editor. Okay. Now, so let's look here, and then okay, so let's look at a little bit closer look at the basic overview of the message loop. So here's what happens. Let's say we have a desktop here and operating system on this side. So on the desktop, we have, let's say, two windows open. So, and our mouse is one of the windows. So when we move our mouse a little bit inside that client area of the window, what will happen? The system is going to generate a Windows message _ mouse move for your application. Okay, it's going to be generated, and then it's going to be stored in the system message queue first. From the system message queue, okay, this message is going to be forwarded to the message queue for your app. So in our case, the mouse is inside the app one, so it's going to go to the post message queue for app one. If it was in the app two, then it will be go to the post message queue app two, will be sent to this way. So this side is done by the system for you. Okay, so you don't have to worry about this area here. Now from this area, from the post message queue, you call the get message function, okay, to retrieve those messages. From this point on, your program takes over. Okay, so let's see here. Okay, here. So this is the message loop in more detail. So here's what happens. So when we call the get message, we pass the message structure by reference. We pass null for the window, so we want all messages for all windows basically that belong to our application, and there's no filtering. So we put 0 and 0. Okay, so what this get message is going to retrieve the message from the message queue for our application, and we're going to check return value. If the return value does not equal 0, we're going to proceed. So if it's not equal to 0, one of two things can happen. Either A, we have received a -1 at the moment. This could change in the future, but at the moment, if we get -1, that means there's something wrong with the message. There's an error. Either the handle wasn't valid to the window or something like that. Okay, so it's a critical error. So we're gonna basically what we're gonna do. We can write code to recover from that error, or in our case, we're gonna basically just display a basic message to the user, and we're gonna return from the application. We're gonna exit the loop, which is gonna end the application. If we have something not -1 and not 0, then there's going to be else statement here, and we're going to go past this message that we just retrieved. We're going to pass it again by reference to the dispatch message, which in turn the dispatch message is going to call the correct window procedure for us. Okay, so that way it goes to the correct window procedure to be handled in the application. So we're going to discuss the window procedure in the not so distant future in more detail, how it handles the messages. Okay, and let's see here. Did I cover everything here? Should I cover it? Yeah, so I covered this. Post structure, type definitions, yeah. So I covered basically, yeah. So let's go back to the code. So just reiterate here. So we have our get message function, gets a message. We retrieve the message by reference. Okay. We check for the error. If there's no error, then it goes to the dispatch message, and dispatch message calls the right window procedure. And this loop repeats as long as we don't get, as the return value is not 0, which is basically WM underscore quit, VM quit message. If we get a VM quit message, this loop will end, and it's going to return here, and it's going to end the program at this point. Okay, so let's run it. So here's the code. So yeah, so basically we are running the code. And then when we click X, when we click .x, VM quit message at some point appears in the post message queue structure, post message queue, and then it ends up in the message queue with the return value gets 0, and then we exit from there. So it was a little bit of time consuming. So to write a basic code in Windows program, it takes a little bit of time. Okay, but it's not as complicated. And in the next videos, I'm gonna go over some more stuff from this code, and also we're gonna probably look into the window procedure. Okay, how the window procedure links into the code that we just wrote, the main procedure. Okay, thank you.